All right, welcome. My name is Brandon Clayton, the Algebra Guy. Today, we will be covering how to solve probability problems step by step. Now, you can see on your screen, this is the basic gist of probability. This won't be very long, but I want to give you an idea of how to solve basic probability problems. So, you'll understand this equation as we go through. You're going to see it pop up again. But the probability of any event is really going to be the number of times your favorable outcome is divided by the total of outcomes possible. So let's look at that. First, we're going to start out, as usual, with the questions that we want to answer for today. So let me pull that up. So our questions are, how is the probability of an event calculated, and how do we represent the answer as both a fraction and an equation? So looking at that now, the probability of an event is the number of favorable outcomes divided by the number of total possible outcomes. And you can think about that even before I look at this situation. I have this banana and apple up here, but I want to just mention one that's very basic just to give you the idea, and the most common one. Hopefully it doesn't bore you, because I'm sure you're going to see it again if you're discussing the idea of probability. But let's say we had a coin, right? And on that coin, it's a two-sided coin. Here's a head. Man, that's a good coin. Look at that coin. That's a United States coin of some sort. That's a good drawing. Don't talk about it. All right, so we got a heads, and on the other sides we have tails. I'm not even going to try to draw tails. It's too complicated. But you know that, let's say we wanted to flip the coin. And we're going to ask ourselves, what are the chances of me getting heads? So what are the chances of me getting heads? Well, to think about the chances of me getting heads, I'm going to think about what I'm really asking is, what's the probability of an event? In this case, the probability of getting heads. What's the probability of getting heads? Well, that's going to be equal to the number of favorable outcomes. Let's say we wanted heads. So we wanted heads. So how many total heads are on this coin? Well, that's going to be easy. It's just one head divided by how many total number of outcomes are there. So how many outcomes could there be when I flip this coin? I could either get heads or tails. So that's two possible outcomes, giving me 1 out of 2 chances. And the other I like to use is that of a die. And yes, that's the singular for dice, which is plural. So here's a little die, and I can't draw it perfectly to show you all the parts. But on that die, you have how many sides? 6 sides. 6 sides. Now let's say we wanted to get a 3. I like the number 3, so I'm gonna use a different color. Make sure this is clearly distinguished from our last problem. So let's say we wanted to get a 3. We want the probability of getting a 3. And that's kind of how you would abbreviate it there. So the probability of getting a 3, well, let's think about it. The number of favorable outcomes on a die. How many possible 3s are there on a die? Well, there's one possible outcome of a 3. And how many total possible events could happen on this die? I could get a 3, a 2, a 1, a 4, a 5, and a 6. So, there's 6 possible chances. So the probability of this event happening would be 1 out of 6. I could go even further later in our discussions to talk about what is it look like as a decimal, and that would be 0.5 for the heads and tails. And here it'd be about, let's say approximately, because I'm not going to write this decimal perfectly because this is a repeating decimal, but it's going to be something like, let me approximate this. So that's approximately 0.17. So I'm going to say approximately 0.17. And we can go to percents and talk about what those look like as percents. 50% and 17%. But that's the big idea. Now I put these on this apple and banana here to make an illustration as well. If I had 3, let's say, bananas, and I had, let's say, 5 apples, and I asked you, what's the probability of pulling out an apple? So 1 apple. What's the probability of getting an apple? So what's the probability, really I'm asking, what's the probability of pulling an apple out of that basket? So my basket, here's my fancy basket right here, has 3 bananas and 5 apples. Well, the probability is going to be the number of favorable outcomes. Well, the number of favorable outcomes, I have 5 possible apples. And I'm going to divide that by the total number of outcomes it could be. I could get an apple, an apple, an apple, an apple, an apple, or I could get a banana, a banana, a banana. I could get 8 different possible outcomes there could be. So this would be 5 over 8. So my probability of getting an apple would be 5 out of 8. So hopefully that helps at least break the introduction for finding probability. The basic definition of probability assumes that all the outcomes are equally alike to occur. So in the cases that I gave you, we're not going to have some apples are really small and some apples are really big and some apples are medium. We're going to assume in probability that all events are equal. We're not going to say that the side on tails is heavier than the side on heads, although I think it is technically. But we assume that all sides are equally alike. Now, if you go on in your studies with math, you'll find that there's several other ways to calculate probability. So you can go a lot deeper than this, but this is a good basic intro. All right, let's do some practice here to drive this point home. The ski club is holding a raffle to raise money. They sold 100 tickets. All the tickets are placed in a jar, and I'm going to make that jar. I'm just a visual person, right? And most people are visual learners. So here's our jar, and I should make the hole big enough so someone can get their hand in there. And here's our little tickets, right? And I'm not going to draw 100 tickets. I thought you thought I was going to do that, didn't you? No, I'm not going to draw 100 tickets. That'll take all day. You'll probably fast forward or get bored. Not going to do that. But I'm almost there, so why not? No, I'm just kidding. All right, so assume that this is 100 tickets in here. That's much better than writing all those tickets. And we have 100 tickets. Now, one ticket, move this out the way, one ticket will be pulled out of the jar at random, and the random will receive a prize. Sherry bought one ticket. So here's Sherry, lucky Sherry, right? Or is she lucky? Let's find out the probability of her winning. First part, let's find the probability that she will win the prize. What's the probability? Well, I remember that to find probability is going to be probability of some event, let's say any event, is going to be equal to the number of favorable outcomes, or some books say desired outcome, and you're going to divide that by the total number of outcomes that you can possibly get. So I'm going to remember that when I try to think about her probability of winning. Well, in order for her to win, that's the favorable outcome. How many chances does she have to win? Well, she only bought one ticket. If she wanted to increase her chances, she could have bought more tickets. So her ticket, I'm going to highlight here in red. Bam. So that's her one ticket right there. And a sea of blue tickets all over the place. There's 100 of them, right? So what's the chances of her winning? Well, her chances of winning is going to be simple. Number of favorable outcomes. Well, she only has one favorable outcome. I should put number 1. I'm just going to write 1. 1. And a total number of possible choices there could be. Well, there's 100, unfortunately, for her. And I say unfortunately because it's not that great. 1 out of 100. That's a pretty slim chance. Now, if I want to write that as a decimal, we know that the hundreds place will look like this. And if I wanted to push it even further and say, what does it look like as a percent, which we'll get into later, this would be 1%, which means per 100, 1 per 100. So we'll talk more about that later. So convert it to a fraction. We just did that. So we took care of both of those pieces. I'm sorry. That's a decimal to a fraction right there. Bam. Next problem. 3 women and 5 men are interviewed for a job. One of the candidates will be offered the job. Find the probability the job is offered to a woman. What's the probability that this job is offered to a woman? Again, I'm not going to write out the formula, but let's remember, for a probability of any event, okay, I'm going to write it out because now I just want to visual, right? I want to see it. So probability of any event is the number of times the favorable outcome happens, divided, says it's the favorable or desired outcome we're looking for, divided by the total possible outcomes you can get. In this case, instead of event, we want the probability that it's going to be a woman. So what's the probability that it's going to be a woman? Well, the number of favorable outcomes. Well, there's 3 women. So there's 3 possible choices there out of a total of what? Now, don't make a mistake of saying 5. Because the total is going to be how many? 5 and 3. So it's total 8 people. So the chances of there being a woman is going to be 3 out of 8. So let's write that as a decimal for our part B. I'm going to write that as a decimal. We'll just remember what we talked about before as far as going from fraction to a decimal. We're just simply going to have to divide, because 3, this is the same thing as saying 3 divided by 8. Well, what is 3 divided by 8? Let's do it. 3, let's do it right here. 3 divided by 8. I want a different color for some reason, so there we go. 8 goes into 3, can't do that. So we got to do that. Make a decimal, so it's going to be a fraction. I'm going to draw a 0 there to make this 30. 8 goes into 30 3 times. 8 times 3 is 24. Subtract those, it gives me 6. This is going to be 0, which I bring down. 8 goes into 67 times, because 7 times 8 is 56, leaving us with only 4. Add another 0 to continue that decimal. And 8 goes into 45 times. And I'm done, because 8 times 40 is 40, which gives us 0. Now I know my decimal is going to be 0.375. 75. So did we answer the probability? Yep. 3 out of 8 was that as a decimal, 0.375. How is the probability of an event calculated? So we just talked about dividing the favorable number of possible events that can happen divided by the total, and that will give you our probability. Now, how do we represent the answer as both a fraction and an equation? We chose that as well. So once we got that fraction, we just changed it into a decimal by dividing the numerator by the denominator. Guys, thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next class.